Welcome back to third lecture on Class 10 Science, Chapter 10, Light. In this lecture, we shall discuss two important formulas of reflection of light, that are mirror formula and magnification. But before learning them, let's understand the sign convention followed. So while dealing with the reflection of light by spherical mirrors, we follow a set of rules called the new Cartesian sign convention. So let's understand these rules. So the first rule is that the pole of mirror is always taken as the origin. Second, the principal axis is taken as the x-axis. Third, the object is always placed on the left side of the mirror. That is, light always falls on the mirror from left side. So always while making a ray diagram, we place the object on the left side of the mirror. And this is done so that the light always falls on the mirror from the left side. All the distances to the right of the pole are taken as positive, while those on the left of pole are taken as negative. So this means that if some distances are on the right side while some are on the left side, then all the distances to the right side of the pole are taken as positive and all the distances to the left side of the pole are taken as negative. And all the distances above the principal axis are taken as positive and all the distances below the principal axis are taken as negative. So these sign conventions are very important while solving the numericals and we must remember them. So let's discuss the first formula, that is mirror formula. Now before learning about the mirror formula, there are some important terminology. So V means the distance of image from the pole. U means the distance of object from the pole and F represents focal length. So the mirror formula is that 1 upon V plus 1 upon U is equal to 1 upon F. That means 1 upon image distance plus 1 upon object distance is equal to 1 upon focal length. And this formula is applicable for all kinds of spherical mirrors. But we must use the sign convention while substituting the values of V, U and F in this formula. Now in this mirror formula, if there is negative sign with the image distance, then the image is real, and if there is positive sign with the image distance, that is V, then the image is virtual. So negative sign, image is real, positive sign, image is virtual. And this is, you have to remember this, and on basis of this we will be solving many numericals. So now let's solve a numerical based on mirror formula. And this numerical is from example 10.1 of NCERT textbook. So the numerical says that a convex mirror has a radius of curvature of 3 meter. If a bus is located at 5 meter from this mirror, then find the position and nature of the image. So basically we are having this convex mirror over here, its pole, focus and center of curvature. And now a bus is there which is at a distance of 5 meters from the pole. And now it is saying that it has a radius of curvature of 3 meter. So this entire distance is 3 meter. This radius of curvature is nothing but the distance between the pole and the center. So now we know that radius is 3 meter. So therefore we can say that focal length will be half of the radius. It will be r upon 2, that is 3 upon 2, that is 1.5 meter. This is because radius is equal to twice the focal length. We have already studied this in the first lecture. So now this distance will be 1.5 meter. Now it is saying that we have to find the position and nature of the image. So first you have to find the distance of the image that is formed from this mirror. Now for this what we will do is we will apply the mirror formula. Now for mirror formula we need 3 things. The first is focal length and we have got the focal length. The second is we need the distance of the object from the pole and the distance of the image from the pole. So we have to find the distance of the image. So distance of the object from the pole will be 5 meter, as the bus is placed 5 meter from the pole. So this u becomes 5 meter, and we have to find the image distance. So we have to find the v. Now just we have to apply the mirror formula, that is 1 upon v plus 1 upon u is equal to 1 upon f, and just put the values. And now before putting the values, one important thing is that we must follow the sign convention. So we must put the plus and minus signs. Now if you observe that focal length is to the right hand side of the mirror, so we will take focal length as positive. Similarly, this u, that is object distance, is to the left side of the mirror, so we will take it to be minus 1, and v we have to find. So if we put the formula, then we will get 1 upon v plus 1 upon minus 5 is equal to 1 upon plus 1.5. Now if we take this to this side, we get that 1 upon v is equal to 1 upon 1.5 minus 1 upon minus 5. Now as there are two minus signs, so both of them will get cut and you will get a plus sign. So basically 1 upon v is equal to 1 upon 5 plus 1 upon 5. Now we just have to solve these fractions and do the sum of these fractions. So just we will do 5 plus 1.5 upon 7.5 6.5 7.5. So I am taking it here. So now from here we can get that 1 upon v is equal to 6.5 upon 7.5. Now if we transpose it, that is if we take this v up, then we will get that v is equal to 7.5 upon 6.5. We just take the reciprocal and we got this. Now if you solve this value, these decimals, if you divide the decimals, then you will get that v is equal to 1.15 meter. This is the final value of v. And now from here we can get that as this value of v is positive, so the image distance, that is also positive. And as the image is positive, image distance is positive, so we can say that the image is formed on the right hand side, that is the image is formed behind the mirror. So as the image is formed behind the mirror, we can finally say that the position of image is 1.15 meter behind the mirror. So we have solved one part of the question, and now let's solve the second part, that is nature of image. So for nature, I just told you that whenever there is positive sign in the image distance, whenever there is positive sign with the v, then always it is a virtual image is formed. So positive sign means virtual image. And as a virtual image is formed, always a virtual image is erect. And also in the previous lecture, that is second lecture, when we have studied the image formation and convex mirror, we learned that whenever the image is formed between the pole and the focus in a convex mirror, then always the image is diminished. That is, image is smaller in size than the object. So basically we have got all the three properties, that are the image is virtual, the image is erect, and the image is diminished in size. In the second lecture, when we studied image formation by convex and concave mirrors, we saw that the image can be equal to the object in size, smaller than the object, or larger than the object. So how to find the magnification of the image? So for this we have a formula, that is called magnification formula. So let's study this. So to calculate the magnification, we have two formulas. The first formula says that magnification is equal to the height of image divided by the height of object. So magnification m is equal to h dash upon h, in which h dash represents the height of image and h represents the height of object. But there is another formula. This says that magnification is equal to minus of image distance divided by object distance. That means magnification is equal to minus V upon U. Now, if magnification comes out to be greater than 1, then the image is magnified. But if the magnification comes to be lesser than 1, then the image is diminished. This means that the image is smaller in size than the object. And finally, if the magnification comes to be equal to 1, then the image is of same size as the object. So magnification greater than 1, image is larger than the object. Magnification lesser than 1, image is smaller than the object. Magnification equal to 1, image is same size as the object. Now here we have another note. So negative sign in the value of magnification indicates that the image is real, and positive sign in the value of magnification indicates that the image is virtual. So now let's solve a numerical based on magnification. So in this numerical, it says that a concave mirror produces 3 times magnified real image of an object placed 10 cm in front of it. Find the image location. So basically we are having a concave mirror, and in that concave mirror object AB is placed in front of it. That's 10 cm in front of it, and then the image is 3 times magnified. That is, the image that is being formed, it is 3 times magnified, and we have to find that what is the image location. So basically, applying the magnification formula, for that, the first thing we know is that we know the object distance. So we know the distance between the object and the pole, that is 10. So U is 10. And now as this object is placed to the left side of the mirror, so that's why a minus sign will come along with it, because according to the sign convention, all the distances to the left side of the mirror are negative, and all the distances to the right side are positive. And we have to find the image location, we have to find the V, and we are also given the magnification. That is, magnification is 3. Now one thing we notice is that the image is real. Now I told you earlier in that note that whenever a real image is produced, then always there is negative sign with the magnification. So real image means that magnification will have negative sign. That's why magnification will be minus 3. So we have put all the sign convention, and now just we have to apply the formula. So the formula is that magnification is equal to minus V upon U. Now putting the values, minus 3 is equal to minus V upon minus 10. So this minus sign will get cut. Now we will take it here. So it will be minus 3 into 10 is equal to V. So basically V is equal to minus 30. So basically we have got that the image distance will be minus 30. Now minus sign indicates that again the image is to the left side of the mirror. So basically if we extend this, then the image will be formed somewhere here. This will be 30. So from this we can infer that the image is formed 30 centimeter to the front of the mirror. With this, we have come to the end of this lecture and reflection of light. In the next lectures, we shall discuss refraction of light. So stay tuned.